So in this video, we're going to look now at the negative gradient, the case where the gradient of a straight line is negative. So let's see. Y equals to, let's start with minus x. Okay, there it is. And the gradient is just -1. Now let's see what happens if the gradient is bigger than -1. Now I want you to think of the number line, because I know you guys might jump to say, oh, -2 and all that. No, -2 is actually less than -1, okay, less than -1, so to say. So let's just think carefully here. Okay, so here the gradient here is equal to -1. So we're going to see what happens when the gradient is actually I started by saying what? Or bigger than -1. So if it is bigger than -1, so we are talking now y equals to, let's say, minus x over 2. You see what is happening? It is bigger, okay? Because -½ on the number line is on the right-hand side of -1, okay? Maybe I should actually, here's the x-axis. Check this instead of trying to explain this. Look, -1 is here. -½ is somewhere here. So this thing here is bigger than that. I want you to understand that -2 as it is here, it is actually less than -1. So I need you guys to really make peace with this and make sense out of it, most importantly. So let's see that is the case. Let's see what if this is -1/3, okay? So if the gradient is -1/3, I should probably put in different colors, and so that we can differentiate on what is happening here. And then let's see, what about -1/5? Okay, there we are. Once again, you can see what is happening. It is getting more and more inclined actually to the x-axis. Not C -1/8. Oh, sorry, I have two negatives. So what it does is it makes it positive automatically. So, but now that I fixed that, so you can see I have a proper desired graph. So you can see what is happening. This is a case where, let me write this down. These graphs here, the gradient is between 0, okay, and -1. Not equal to 0, neither equal to -1. So obviously we can expect the gradient for the lines that I'm going to draw now here to be actually greater than 1. Sorry, not greater than 1, excuse me, less than -1. So that's what I'm going to have here. This case, we're going to expect the gradient to be less than a -1. And so what will be that case? So it will be obviously your graphs like y equals to -2x. You can see where that is going. Here it is. Where we can get a different color like that, pink. Then let's say y equals to let's go for -5x. There we are. There it is here. Okay, so just gonna give that maybe purple. There we are. And we obviously now know what will happen maybe if I have a -10x. I set positive there, so I must have a -10x. We can see again it is getting closer, much closer, more closer, way closer to the x-axis. So this is the important part that I want you guys to get, so that whenever you plot straight lines, you know exactly where the line should lie on the Cartesian plane. You know which side should be on the positive y-axis, which side of the line should be on the negative y-axis. So notice that all lines that have a negative gradient will always be in a sort of decreasing form. In other words, they will this is decreasing. When you check left to right, you realize that actually y values are decreasing. Okay, so that is why we say it's decreasing, because the y value here and the y value there, if you look at the change, we moved from 7 to 6, now we're moving to 5, now we're moving to 4, now we're moving to 3, we're moving to 2, we're moving to 1, 0, now we are at -1. So you can see, as you look at this function, the y values are decreasing. That's why we say the function is decreasing as well. Okay, when if you want to know whether the function is decreasing or increasing, you actually look at the y values. You check the y-axis. What is happening as you read the function from left to right? Okay, from the smallest x value to the biggest x value, what is happening to the y values? That is a very, very critical concept for you to understand, because you are going to get questions like, for which x values is the function increasing or the function decreasing? Okay, so I need you to make sure you understand that. So obviously, if we are to look at the case of a positive gradient, which I have already spoken about in the previous video, but I did not really mention this, you can see also that we have a case here where now x values, as x values increase, the function is also doing what? Increasing. So you can see now, if I read here, I had a y value of -4, now I'm having -3, and -4 is smaller than -3, so it's increasing. You can see -2, -1, 0, and I'm moving there to 2, to 3, to 4, etc. So you can see this one is definitely increasing. So what you need to understand is that when the gradient is positive, okay, then you have an increasing function. So let me clear this and make my story very simplified for you. Okay, so this is very important for you guys. Whenever the gradient is increasing, whenever the gradient is positive, then your function, whether f of x or g of x, is then increasing. That's one important thing that you need to note. If the gradient is negative, so we established this, if the gradient is negative, so we're going to have a function like this, so you know that your function is decreasing. And you realize this is the case even in the other functions that we are going to study. So I want you guys to hang on to this, hold on to this knowledge. We will start looking at functions and real life applications of functions, but we will get to that as we move on. For now, I just want you to internalize this concept and understand actually what is the effect of the gradient. So in the next video, I will then now talk about the effect of the y-intercept. That is, remember, we have the form y equals to mx plus c, or y equals to ax plus c. So in fact, if you don't want to say m there, you can say a, and here if you don't want to say m, you can say also a. And so now in the next video, this is a q usually, remember. So in the next video, we're now going to talk about c and q. We have spoken about the gradients. Now we're going to talk about the intercept. Cheers.